In this video, we are going to discuss about ELVIS, which is a data acquisition system used in LabVIEW environment. It utilizes RS-232 and GPAB for its interfacing abilities that we will see in a detailed note. ELVIS is looking as in the figure. It is a data acquisition system which includes external features which include the scope, data multimeters, function generators, and internal power supplies. It also have analog inputs and outputs and digital inputs and outputs, which are used for interfacing the external field device data into a PC with LabVIEW. The specifications of ELVIS is listed here. It has a breadboard for making circuitry and its testing. It also has interactive soft front panels with the inbuilt virtual instruments. It is fully integrated with the Multisim, which is a platform used for simulation purposes, and it is having APIs, application program interface, supported with the LabVIEW and text-based languages. So its operating speed is up to 100 megasamples per second, where the scope which is utilized in this ELVIS have a high resolution data rates, and it also have a digital multimeter with the 5.5 digit capacity and 16 analog inputs with the 16-bit resolutions is also available, and 24 digital inputs and outputs along with the 15 PFIs are being uh, available in the ELVIS 2. In ELVIS, we have multimeters, function generators, and oscilloscopes. And this is the visual idea of the operating multimeter in ELVIS. And ELVIS is nothing but an educational laboratory virtual instrumentation suite where this provides a data acquisition system where the external world informations are collected from this ELVIS and displayed in the PC itself. So PC acts as a virtual instrument and it is coordinated by LabVIEW assistant by the name Visa. Visa is nothing but the virtual instrumentation software architecture which provides communication between the field device and the PC by the use of these uh, connectivities, where GPIB 488.2 is a standard communication protocol where it provides parallel communication. Similarly, we have uh, PXI and VXI cards available. Along with that, we have USB and Ethernet communications are also available. So an instrument which is showing real world data can be interfaced by the PC through this VISA architecture. Here, two things are highlighted and it is predominantly used, and they are RS-232, which is a serial communication, and GPAB, which is a parallel communication that we are discussing in this lecture. So serial communication is nothing but a data transfer in a single wire where data are transmitted as a bit by bit data. And here in parallel communication, data are sent in multiple wires where the transfer rate is fast when compared to serial communication. So as per the requirements, we will choose either serial or parallel communication for our application. Here, a computer can be interfaced to a real instrument where the data have been transferred either by the use of LAN or by the use of GPAB, where LAN is working with the RS-232 and GPAB is working with its 488.2 standard architecture. RS-232 is a 9-pin configuration where it supports serial communication and the serial communication is established by handshaking kind of things. Those provisions are provided by these pin diagrams, where first pin is a ground, second pin is a data terminal ready pin, where the terminal which is used to as a transmitter or receiver is ready or not, and third pin is the receive data, where whether the data is received or not, and fourth pin is transmit data, whether the transmission data is available or not, and DCD is the data carrier detects, where data has to be detected for making a communication establishment, and DSR is the data set ready, where DSR ensures the data, the burst of data is ready to send or not. CTS is nothing but the clear to send, where if a data is collected, once the port has to be cleared, then only they can make a communication. So that is provided by CTS, and RTS is the request to send, which is the one which sends the request signal from the transmitter uh, to make a communication establishment. And the ring indicator is nothing but the indication of the transmissions is possible, is working or not. So RS-232 is a serial communication standard which has two ways of making communication establishment. One is asynchronous and another one is synchronous. So asynchronous is the way of communicating from transmitter to receiver with the start bit and the stop bit. Here, the data which is in logic 1 are categorized with respect to a particular pattern, and it is asynchronous. So, by the way, start bit indicates the transmitter is transmitting data, and the receiver will collect the information, where 8-bit data are available here. And once it sees the stop bit, then it uh, that stop the transmission, and it freezes the data as 0 to 7. In terms of synchronous data, it has both data as well as a clock, where the transmitter and the receiver will be locked with the clock signal. So this lock indicates the communication establishment at a particular speed, and the data in transmitter and receiver will have a same speed as in the baud rate, where 9600 and 1,15,200 is the standard communication baud rates. And this RS-232 is a low cost and point-to-point communication protocol. So transmitter and receiver is a one-to-one communication protocol. And the second thing is GPAB, where GPAB's layout is here. It is a 24 pin layout, which includes data inputs and outputs. So we have uh, um, digital data inputs as well as outputs are collected here. And apart from that, it is having multiple features corresponds to handshaking kind of things. So there are handshaking. For handshaking, it has three buses available. One is handshaking bus, another one is management bus. So that transmission has to be managed without any data collision is ensured by management bus, and finally with the data bus. So multiple nodes or multiple devices can communicate in by the use of this GPAB. So that is a specialty of GPAB. So if you see here, the GPAB listener or talker can work in a parallel way with with the sharing of these three buses. So one more diagram shows a pictorial representation of devices which are communicating with GPAB IEEE 488 bus. So this bus is having the same kind of three handshaking signals, where data line is here and handshaking lines are here, and the management of the control lines are here. So these lines are and its control is with respect to these three lines, and the devices A, B, and C, D, etc. or taking the connection with the 24 pin connector, and once it is connected, this either it is a computer or it is an instrument or it is some other handheld devices, then they can take the data from this particular lines with the appropriate control provided through the control signals. So by the way, this is a high speed communication when compared to RS-232, and it can support device connection up to 15 number of devices. It uses addressing system for making proper data retrieval and storage. And comparing this to where RS-232 is a serial communication and it is parallel communication GPAV, and here it is supporting the low speed data transfer, and it is of high speed data transfer. The device will have only one data can be connected, one device can be connected at a time. Here 15 devices can be connected in a single shot. Here the distance is longer connection, where either if you are using Ethernet cable, then you can make a longer connection. But here it is very short, where this GPAB cables are having a restriction in the length, and cost wise it is low and it is high. Complexity wise it is very simple and it is very complex. Thank you.